Good day everyone. So today we will discuss the module 3. It's all about the limits of transcendental functions. Most of the algebraic expressions like y is equal to x squared plus 6x minus 2 and y is equal to x plus 2 are composed of letters or variables and numbers. So they are often used for the application of limits, but for this lesson, non-algebraic expressions, which are called transcendental functions, will be utilized. So this lesson, this will focus on transcendental functions. The lesson objectives: first, we are going to compute the limits of exponential, logarithmic, and trigonometric functions using table of values and graphs. And we are going to illustrate the limits involving the expression sin t over t, 1 minus cosine t minus t, and e raised to t minus 1 over t using table of values. So what are transcendental functions? So these are the functions that cannot be expounded in algebraic form. Some examples of transcendental functions are exponential. We have f of x is equal to 10 raised to x plus 1. Logarithmic example, we have g of x is equal to logarithm of x minus 2. And trigonometric example here, h of x is equal to sine of x plus 3. So the method that will be used in solving the limit of transcendental functions is also table of values and graphs. The example number 1 for exponential function, we are going to solve the limit of 2 raised to x as x approaches to 2 using table of values and sketch each graph. So for the solution, we are going to create two tables of x value that approaches to 2 from the left and from the right. So here for the x values, as x approaches to 2 from the left, so we have 1, 1.9, 1.999, and 1.999999. And as x approaches to 2 from the right, so we have 2.001, 2.005, 2.01, and 2.1. Okay, so let us solve now for the values of y on the first table. So if x is 1, the value of y is 2. If x is 1.9, the value of y is 3.73213196. If x is 1.999, the value of y is 3.972369982. And if the value of y is 1.99999, the value of y is 3.99722837. Okay, how will you solve for the values of y? The given function is 2 raised to x. So we have f of x equal to 2 raised to x. So let us solve for if x is 1. So we have f of 1 is equal to 2 raised to 1. So substitute 1 to variable x. So therefore 2 raised to 1 is equal to 2. Next, solve for f of 1.9. So the value of x here is 1.9. So let us solve. So this is equal to 2 raised to 1.9. So this is equal to 3.73213196. Okay, this one. Next, f of 1.999. This one. So this is equal to 2 raised to 1.999. So this is equal to 3.9723699982. Okay, here the value of y. Next, How about if x is 1.99999? So this is equal to 2 raised to 1.999. That is equal to 3.997228372. Okay. Okay, so let us solve now for the values of y on the second table. So you have now the values of y. So if x is 2.001, y is equal to 4.0027755. If x is 2.005, the value of y is 4.013886994. If x is 2.01, the value of y is 4.0278222. If x is 2.1, the value of y is 4.287093885. So how will you get this values of y? Okay, so same procedure on the first table. So we have now the function f of x is equal to 2 raised to x. So if x is 2.001, so we have 2 raised to 2.001. Just substitute the value of 2.001 to the variable x. So we have the answer is 4.0027735. Okay, this one. Next, how about if x is 2.005? So this is equal to 2 raised to 2.005. And this is equal to, by the use of your calculator, we can get 4.0138869994. This one. Okay, next, if x is 2.01, this is equal to 2 raised to 2.01. Okay, so what will be the answer? So we have 4.0278222. Okay, and the last one, how about if x is 2.01? This is equal to 2 raised to 2.01, and the answer is 4.287093885. Okay. So what will be your observation? As x approaches to 2 from the left, what will happen to the values of y? And as x approaches to 2 from the right, what will happen also to the values of y? Okay, so for the observation, as the x value approaches to 2 from the left and right, the y value approaches to 4. Okay, this one. 3.9997, this is approaches to 4, and here is 4.0027735 approaches to 4. Okay, so after the y values in both tables were solved, determine the one-sided limits from the left and from the right. So the limit of 2 raised to x as x approaches to 2 from the left is equal to 4, and the limit of 2 raised to x as x approaches to 2 from the right is 4 also. So since both one-sided limits from the left and right is equivalent to 4, therefore the limit of the function 2 raised to x as it gets closer to 2 is 4. So the limit is written as the limit of 2 raised to x as x approaches to 2 is equal to 4. So let us graph now the function f of x is equal to 2 raised to x. So this will be the graph of the function, exponential function 2 raised to x. And this will be the enlarged illustration of the coordinates plotted on the Cartesian planes. So by the use of these points, the first table and the second table, we can have these points. Okay, so it is visible that as x approaches to 2 from the left and from the right, the y approaches to 4. Okay, here. Okay, let's have now example number 2 for logarithmic functions. So find the limit of logarithm of x to the base 3 as x approaches to 1 using table of values and sketch each graph. So for the solution, again, you are going to create two tables of x value that approaches to 1 from the left and from the right. So as x approaches to 1 from the left, So we have 0.8, 0.9, and 0.99. And as x approaches to 1 from the right, so we have 1.1, 1.01, and 1.001. Okay. Okay, let us solve now the values of y if x approaches to 1 from the left. So we have here now the values of y. But how will you get this one? Okay. So our given function here is f of x is equal to logarithm of x to the base 3. Okay, let us solve y if x is 0.8. So we have f of 0.8 is equal to logarithm of 0.8 to the base 3. So just substitute 0.8 to the variable x. And by the use of our calculator, we can get the value. Okay, so this is equal to negative 0.203114013. Okay, here. Next, if x is 0.9, so we have f of 0.9 is equal to logarithm of 0.9 to the base 3. And the answer is equal to negative 0.095903274. Okay. And the last one, get the value of y if x is 0.99. So we have f of 0.99 is equal to logarithm of 0.99 to the base 3. And this is equal to negative 0.009148029. Okay, so we have now the values of y as x approaches to 1 from the left. Okay. Let us solve now the values of y as x approaches to 1 from the right in the second table. So we have here now the values of y, but how will you get this values of y? Okay, so same procedure on the first table. So our given function is logarithm of x to the base 3. Okay, so get the value of y as if x is 1.001. So we have f of 1.001 is equal to logarithm of 1.001 to the base 3. And by the use of our calculator, so we can get negative 0.00909784441 here. Okay. Next, we have if x is 1.01, so f of 1.01 is equal to logarithm of 1.01 to the base 3. This is equal to negative 0.00905718146. This one. Okay. And the last one, if x is 1.1, so we have f of 1.1 is equal to logarithm of 1.1 to the base 3. That is equal to 0.08675564. Okay. So what will happen now to the values of y as x approaches to 1 from the left and as x approaches to 1 from the right? So what is your observation to the values of y? So as the x value approaches to 1 from the left and right, the y values approaches to 0. This one approaches to 0. And here approaches to 0 also for the second table. So after the y values in the tables were solved, determine the one-sided limits from the left-hand side. And we determined already the limits. So we have the limit of logarithm of x to the base 3 as x approaches to 1 from the left, that is equal to 0. And the limit of logarithm of x to the base 3 as x approaches to 1 from the right is equal to 0 also. So since both one-sided limits from the left and right is equivalent to 0, therefore the limit of the function logarithm of x to the base 3 as x gets closer to 1 is 0. So the limit is written as, we have the limit of logarithm of x to the base 3 as x approaches to 1 is equal to 0. Okay, let us see now the graph of the given function. logarithm of x to the base 3. So this will be the function, the graph of the function logarithm of x to the base 3. And this will be the enlarged illustration plotted on the Cartesian plane. Okay, by the use of these points, the first table and the second table, we can have these points. Okay, and it is visible that as x approaches to 1 from the left and from the right, the y approaches to 0. Okay. Example number 3 for trigonometric function. We're going to evaluate the limit of sine t over t as t approaches to 0 using table of values and sketch each graph. Okay, so let's have this reminder in solving trigonometric function. So since the given function is trigonometric function, the calculator should be set in region mode to provide numerical data that leads to the limit of sine t over t as t approaches to 0. In converting the mode of scientific calculator from degree to radian, most of them has a mode button. So just click the mode button. And the calculator's screen presents different modes. And look for rad 2 and hit the number of that mode. Okay? This one, the rad. Now just click the number 2 or hit number 2 of your calculator. Okay, for the solution, we are going to create two tables of values that approaches 0 from the left and from the right. In this example, t was used instead of the variable x. Okay, so as t approaches to 0 from the left, so we have the value negative 0.5, negative 0.2, and negative 0.01. And as t approaches to 0 from the right, so we have the values 0.01, 0.2, and 0.5. Okay, let us get now the y values as t approaches to 0 from the left. And we have here now the y values. So let's have the procedure in finding these y values. Okay, so our given function, we have f of t is equal to sine t over t. So if t is equal to negative 0.5, so we have f of negative 0.5 that is equal to sine of negative 0.5 over negative 0.5. Just substitute negative 0.5 to variable t. Okay, so by the use of your calculator, make sure that it is in radian mode. So this is equal to 0.958851077, this one. Okay, next, f of negative 0.2 that is equal to sine of negative 0.2 all over negative 0.2, that is equal to 0.993346654 here, this one. And the last one, f of negative 0.01 is equal to sine of negative 0.01 over negative 0.01. This is equal to 0.9998833. Okay, this one. Okay, so let us solve now the values of y as t approaches to 0 from the right. So we have here now the values of y. So let's have the procedure in finding these y values. So our given function is f of t is equal to sine t over t. So same procedure on first table. So we have, if t is 0.01, we have f of 0.01 is equal to sine 0.01 all over 0.01. So this is equal to 0.999883333. Okay, this one. Next, f of 0.2 is equal to sine 0.2 over 0.2. So this is equal to 0.993346654, this one. And the last one is f of 0.05 So is equal to sine 0.05 over 0.05. So the value is the answer 0.958851077. This one. Okay, so what will happen now to the values of y as t approaches to 0 from the left and as t approaches 0 from the right? So as you notice, as the t value approaches 0 from the left and right, the y values approaches to 1. Okay, so here this is approaches to 1 and here approaches to 1 also. After the y values on both tables were solved, determine the one-sided limits from the left and right side. So the limit of sine t over t as t approaches to 0 from the left is equal to 1. And the limit of sine t over t as t approaches to 0 from the right is equal to 1 also. So since both one-sided limits from the left and right is equivalent to 1, therefore the limit of the function sine t over t as t gets closer to 0 is 1. So the limit is written as the limit of sine t over t as t approaches to 0 is equal to 1. Okay? Okay class, in graphing f of t equals sine t over t, so this is a trigonometric function. So we use these points to graph that one. So negative 0.5 and 0.958851077. So 0.5 here and here. Okay? And negative 0.2 and 0.993346654. This one. And negative 0.01 here and 0.9998333, this one, this point. Okay, in the second table we have 0.01 here, 0.01 and 0.99833 here, and negative 0.2, 0.2 and 0.993346654, this one. Okay, and 0.5 rather, and 0.9588510077. So this is the graph of f of t is equal to sine t over t. And here in figure 6, you will notice that it is visible that as t approaches to 0 from the left and from the right, the y approaches to 1. Okay, here approaches to 1. Okay class, that's all about the limits of transcendental functions. So if you have questions, clarifications regarding this topic, just comment on this video. Thank you for watching. God bless everyone.